Today we will discuss another cloud design pattern which is called event sourcing design pattern. So what essentially means in event sourcing design pattern is that you are sourcing all the events happening in your journey, and then out of that you are trying to fulfill the business requirements and the transactions. So let's try to understand in very layman. Suppose you have to sell one product. So what all the events will be happening in this one? Customer will go and choose the product. This is one event. Then it will try to go ahead and add it into cart. This will be another event. Then it will do a checkout. This will be another event, and then finally it will be sold. So this will be another event. So suppose for the same product itself, while addition of this product in inventory will happen, then a event add to inventory will get fired. Similarly, those things will be happening. So now if you have to fulfill all the requirements of this thing using this, so what you have to do is out of these events, whatever has been generated, you have to create an aggregate view, and then you have to fulfill. So suppose like for inventory addition, these are the events getting added. So you will be as these are the event sourcing pattern. So in event sourcing pattern, you'll always try to have an append only database, because what we are trying to achieve to avoid all the conflicts. And in append only, you always try to write an immutable object to a DB in an append only manner, so which makes this writing very efficient and fast, because there is no conflict is happening on the update and all those things. So suppose you have added one inventory, it will have one event, then similarly another event. So you have to aggregate these events, and then you have to showcase your home page. So this will be the basic idea. So similarly for addition and checkout and all those things, you have to read all the events of checkout, and then you have to showcase it into the checkout and all those things if someone wants to have it. These kind of events are used in pattern where you have large scale to serve, because append only system are based LSM trees, and these are very highly scalable for writing. So if you have a large scale to serve and a huge domain to serve, then this will be helpful for you. So now let's try to understand it in the depth. So what will happen is that if you have to maintain suppose full audit, just to give you an example, suppose if you are building some courier service. In courier service, they want to see the full trail of it, from where it started, from where it's going, and all those things. In a normal traditional way, what you will be doing, you will be taking one transaction and you will keep status updating same status for the same thing. Suppose if you are building in the normal traditional way, what you will be doing, you will be having one where is the destination in the courier way. So suppose it's at Delhi, then it started it to Mumbai. So you will update obviously the final destination always from Delhi to Mumbai and all those things. So you'll be not be able to play it back from where it all started if you are keep updating the same data. But in append only, what will happen is that once it will get updated Delhi, then it will the same status, same value will get updated to Mumbai, then same will get updated to Bangalore, the same will get updated to other cities. So by this way, once you will with the identifier whatever you have provided, using that, if you will pull this data, what you will be able to showcase is that you will be able to showcase this complete view of the overview of this thing. So if you have to build audit trail by default, or you want to play back certain events or all what all the things has happened on those things, it will be helpful for you to find out this event sourcing pattern. Now comes the next is that if you have too many transactions to update the same data, obviously in DB anything you have to update, it will put a lock on that particular thing, it will pull it, will modify, and it will save it. And if you have too many concurrent users and you have large scale to serve, your traditional transactional thing will not be able to serve it. So you need an immutable objects in append only data structure. Now comes the next is that what are the solutions we will be building with this. What we will be doing is we will be storing all the events in some append only data store, and then we will try to create a materialized view out of it which will showcase the uses. In one example later we will see how this will be done and all those things, how this will be uh, actually executed. For now, what you will be having, we will be having one presentation layer where the overview of all the items will be shown. So how items will be shown? For items, we have to aggregate all the events related to inventory addition, and then out of their final state, you build a materialized view of home page where you will be showing what all the items you have. Then a cart will get created, items will get added into the cart. All those events you'll keep adding. Then address added, checkout will happen, data will get stored in the DB, notification will be sent. And if you have to again show the cart and its items, you have to again create views out of those events so that you can showcase them. Obviously, caching layer and all those things you have to build on top of it. Now comes the advantages part of it. Advantages, it is very good for large scale because objects are immutable and in append only matter. So writing will be pretty fast, just like Cassandra in LSM trees. So now comes the next is it will be very easy for you to play back all the events, what all the things has happened. It will be very easy for you to find out an audit trail and all those things. It will be good for you for concurrent updates because these are only append only, so you can update at large scale. And then for the growth analysis, analytics, and all those things, because you are storing each and every event and action of the user, it will be very good for your ML and AI, all those things. Now comes the next part is what are the issues and considerations whenever we are building we have to keep, because we are creating a materialized view out of the events, so they might be out of sync, so it will be eventually consistent data, it will not be in real time or near real time data consistency, because you are creating a materialized view out of the events and there might be the chances that issues may arise. So if you want a real time consistency, then this system is not for you. There might be the chances that you are trying to book an hotel room in an hotel, and your order of as soon as you will book hotel, it has to decrement a value. Correct, right? So before decrementing itself, again request come and it will read the dirty data. So there might be the chances of these things will happen. So you have to mitigate these things so that it will be easy for you. Now comes the thing is that in case of multi-threaded environment and all those things, you have to make sure that your identifier, because everything materialized view and all those things will be checked on some identifier, because all the events will get added. Suppose for against one event, one two event, two three one three event. But in this case, whenever you will be creating a materialized view, order of the events will be very important. So in to maintain that, you have to do ordering in a manner. So for the ordering and all those things, what you can combine is timestamp with some incremental counter, because if at the same time more than one, as we are looking for large scale, so if at the same time more than one data come, then we will use the those incremental things. Now we have to analyze the data, because these are the append only data structure. Obviously some NoSQL DB you will be using like Cassandra and all those things. So in that one, all those large queries of SQL will not be working. So you have to somehow put some of the stream analysis like Kafka, Spark, and all those, so that it will be good for you to analyze data and put or get the desired result. As we discussed, eventual consistency is one of the things which we are looking for it. Now comes the part when to use. If you have to capture intent, purpose, region, all the behavior of the consumer and all those things, then you should go for this. The next part is you are not looking for a real-time consistency. If you are looking for an audit log, history, state of system, rollback changes and all those things, this system will suit to you. And In there are certain cases when events are natural feature, all the actions are happening in the event. So in that case, obviously it will suit to you. And the next part is if you want to decouple certain things. So suppose some events are happening and there are several services consuming that data. So event will be totally altogether different. Any system whosoever want to get some view out of it, what they can do is create a materialized view out of this and showcase whatever you want to see. Now comes the next part is when not to use. So if you have very small scale to serve and your system is kind of very small or no business logic, not too much of business logic, then it will be fitting. It will not be fitting. If you want real time, then also this will not be fit. If you don't require audit trail and all those things, then also it's fine. If you have very low concurrency or conflicting updates, then also you don't need this. Now comes to the next part. Suppose you are trying to have a booking system in a hall or some conference system. So what will happen is that if you, as soon as you will book a room, you have to decrement its value, and then as soon as you will cancel the room, you have to increment this. So there might be the whole lot of conflicts might be happening. So what will happen in the first case, as soon as you will see user interface, you have to showcase the view. So in a view, what will happen? You will create a seat availability aggregate out of materialized view, and what you will showcase that these many seats are available with the events while seats are getting added. Or normally also you can create a view out of that because this is the repository which you have already created for that particular hall. Then in the next third one, what you will fire is that you will go ahead and fire an event with the seat booking or cancellation. If it's booking, you will increment a value. If it's not booking one or cancellation, then you will, if booking, you will decrement, or if it's a cancellation, you will increment the value. Now comes the part is that in the fourth and fifth, you will fire an event, and similarly, that event also you will be creating a view so that directly you can showcase it to the next user whosoever comes. So as soon as you decrement, you will directly store it here and you will show that this is the person. So here one event is like reserve one seat, reserve two seat, cancel one seat, reserve two or serve two seat. All these events will get fired and booking will continue on that part. So yeah, this is for